Okay, what we have in this slide is two pictures, two diagrams, should I say, to explain or to show what we mean by the stopping sight distance. So you look on the top figure, the car on the left, yes, car on the left, and the value H1 here refers to the driver's eye, the height of the driver's eye above the road surface, whereas H2 is the height of the object on the other side of the curve. So at a point where the driver of this car could see another object of height H2 over the crest, that is what we call as a sighting distance. And if that distance is the minimum distance required for the car, for the driver to react, okay, and to stop, so we call it the stopping sight distance. And in this case, if you roughly, I think we could see that distance there, that line, the length of that line is a bit longer than the length of the curve, which is, I want to use a different color now. Let's say I use yellow. So that is the length of the curve. Okay, starting curve, ending curve. So we could see that the red line is longer than the yellow line. So in this case, the stopping sight distance is longer than the length of the vertical curve. But there are also cases where the stopping sight distance is shorter than the vertical length, the length of the vertical curve. So when we try to decide the best length, the minimum length required, so we might have to consider both cases and see which one is more suitable. And figure beneath it, okay, there's a car going down into a side curve and another vehicle in front of it. So in this case, the sighting during the day, there's no limit for the sighting sight distance, for the sight distance, because you can see, okay, as far as your eyes can see. But however, when it comes to the stopping sight distance, okay, I think you could appreciate that the distance should be a bit different than going up a crest curve, okay? Because in this case, the value hi is not actually the height of the driver's eye, but instead the height of the headlight beam, the headlight, should I say. And on this side, we might have an object, and which is a height, in this case 0, because that light beam will hit the surface of the road. Okay, so we'll take this into account. Okay, how much the light beam is shown by the darker red line. Okay, differ or deviate from the lighter red line there, which is the actual straight line from the headlight. So by a degree, in this case we call it beta. Okay, so there are two cases. Okay, one for crest curve and one for excuse me, side curve. Okay, but our life has been made easier because we've got standards, right? So I think the next slide just shows the standard in JKRs and ATJ. Minimum stopping SSD, okay, for crest curve, and minimum passing sight distance, okay. This is also for a crest curve, okay. Right. There's no passing sight distance for set curve, okay, because you can see as far as I can see. So stopping sight distance, of course, the faster you're traveling, the longer the distance that you need to stop. And in terms of passing or overtaking, okay, the faster you are, the longer the length or the distance that you require, okay, ahead of you in order to overtake another vehicle. Okay, but in most standards, the minimum SSD, okay, the sight distance is the controlling factor, is the main factor considered when designing vertical curve, because using overtaking sight distance or passing sight distance will be uneconomical in many cases, because if you look at 120 here, you need 285 to stop. But if you're going to take into account overtaking, so for 120 you need at least 800, okay, which is a short 200 meters short than a kilometer, which is very long. So that's why in most cases SSD will be used as a controlling factor. Okay, how do we calculate it and how do we determine? Okay, so let's look at the first criteria. We want to determine the length of curve based on stopping sight distance. Okay? So we're going to use that as our controlling factor now, stopping sight distance. So there'll be two cases. Your SSD or stopping sight distance could be less than L, or it could be greater than L, as I shown in the previous two slides in the figure. Okay. Now, if it's less than L, you use the equation. If it's more than L, you use the equation for a crest curve. Okay. For a set curve, you use this set of equation. Okay. Now, so which one would we use? Okay. If you cannot estimate the length of the curve or the length of the vertical curve beforehand, because you know what the sight distance that you require. But the standard says you require a certain length. Then you're going to build a vertical curve, but you're not sure. You're not certain what is the length of the vertical curve needed to provide the sight distance that is required. So in that case, you will probably have to use or calculate both equations. Okay, you compute both equations and see which one is true. We're going to do one example later so that you can see or you can understand what I mean by that. Okay, so that is the equations needed or involved when you are calculating the length of the vertical curve. Okay, when we say length here, the L here is basically the minimum. Okay, the minimum. So let's say you calculated L as, let's give it a number, 254. Okay, so that will be the minimum. Okay, you can make it more than that, doesn't matter, but you cannot go less, okay, than the minimum. So that's stopping sight distance. Okay, and next one. If you are taking into account, or the controlling factor is overtaking sight distance or passing sight distance. Okay, and as I mentioned earlier, OSD or overtaking sight distance considered uneconomical. Okay, and most likely the stopping sight distance is considered as a major controlling, I'm missing a G there, sorry, okay, controlling factor to determine the curve length. Okay, so I think JKR GKR's ATJ adopt this approach or this philosophy. Right. So again, similar. Okay. I got two equations. Either it's less or greater. You might have to calculate both to find which is true. Okay, and H2 when it comes to overtaking, it's a bit different than the previous example. Okay, because I think I forgot to mention it previously. in JKR's ATJ, H1 height of driver's eye is 0.92 in the standard. Okay, whereas the height above the object surface, which H2 is 0.15. Okay, meaning that you're driving, assuming that your eye level, okay, is 0.92 meter from the road surface, and the object over the crest is 0.15 meter. Okay, so that's the standard. Okay, the figure. Different standard use different figures. Okay, but they're more or less similar. Okay, so coming back to the overtaking now. For overtaking, H2 is to be a bit taller. It's a bit higher than H2 in SSD. Okay, in SSD it was 0.15. Now it's 1.35 simply because when we're overtaking, we want to see a vehicle that coming towards us normally at a greater distance. So that's why H2 is higher. Okay, so that's if you're taking into account overtaking side distance as a controlling factor. If you want to take comfort as your controlling factor, excuse me, only applies to set curve though, and the equation is given by this. Okay, P minus Q, the algebraic difference, V velocity, and T95 is a constant. That will give you the length of the vertical curve if you are considering comfort as a factor to determine the length of your curve. Okay, next. Something wrong here. Okay, the K value. Okay, remember I was talking about the K value. The K value is actually by definition is the rate of curvature of a curve, and normally we use this value K to determine the length, the minimum length of the vertical curve, and what it means, what it says, or what does K stand for? Well, if you should know is K is the value of the horizontal forward distance, okay, measured on the curve that give rise to 1% change in the slope. Okay, so that's how far do you go forward on the curve to get a change in slope for 1%. So in other words, that's what it says. That's what it means by the rate of curvature. And if we take that into account, if we take that value K, so the length, okay, of a vertical curve can be simply computed by that simple equation there. K multiplied by the algebraic difference. Okay, and again, you could calculate K manually if you like. Okay, but I'm not going to show you here. But if you refer to the recommended text, you can find how K is derived. But luckily enough, in any standards. Okay, value K has been calculated and has been tabulated against speed. So if you know your speed, for your design speed, you can immediately find out what the minimum K is. Okay, so these two tables, that one is for crest curve and that one is for sag curve. So these are values from JKR's ATJ. Okay, so looking at that, using those values in the table, we can easily obtain what the value or what K, what's the length of the vertical curve needed. Okay, quite straightforward. L is equal to K value multiplied by the algebraic difference. So in some text you might see equation that says KL is equal to KA. Okay, which is the same thing. Okay, it's just a matter of expressing algebraic difference either P minus Q or A. So that's K value. All right. So when we do set out vertical curve, okay, what we are required to do, we have to put some kind of stakes or pegs or piece of wood, and we have to put some information on that particular stake, just to show, in this case, okay, chain edges and some kind of reduced level. Okay, I'm not sure in this picture though. Probably that point is 386 reduced level. It could be in feet because I've taken that from the internet. Could be in the US. Okay, they still use feet, so it could be 386 feet at that point there. So when the road builder comes, so they know, okay, at this point how much they have to fill it up or have to cut it down to get to the vertical curve required. So similarly here, pegs are marked at regular interval, and each of the pegs would have information on the radius level. So because when you construct a vertical road curve, when you set it up, you will set it up on existing ground, but when you're going to build it, they have to either remove the ground to the required level or fill the ground to the required level. So that's why we need some kind of reduced level information on the stakes. Okay, let's look at one example. Okay, let's look at one example here. So it says here, a vertical curve is to be constructed to join two grades or two gradient plus 2% and minus 1.33%. So it says that if the stopping side distance SSD for the driver whose height is 1.05 meter and object height is 0.3 meter above the road surface is 200 meters. So the SSD required is 200 meters. So calculate the length of the vertical curve required. Okay, so you were told your gradients are plus 2 minus 1.33. Height of the driver I is 1.05, height of object is 0.3, and SSD required is 200 meters. So what is L? So that's what basically the question. So we've got to solve that now. Based on the information given in the question, we have to establish, okay, whether S is greater than L, whether S is smaller than L or shorter than L. But as at that point we don't know. We were not told. We don't have any idea. So as I was mentioning earlier, we have to compute both equations. So let's look at S less than L. So when I put all the numbers in there, P, that's Q, that is SSD, then SSD, then P and Q, I obtain 269. Okay, but this one's supposed to be S smaller than L. Okay, S shorter than L, I say. All right. Now, L is 200 and L is 269. S 200, L 269. So it looks like it's true. Okay. Let's try the second one then. For the second equation. Okay. 2 SSD, which is 2 times 200, multiply by all that. Okay. And we ended up with 251.65. Okay. 251.65. So, in this case, S, which is 200, is not greater than L. Okay, so that is false. So we have to do both. Okay, so in this case, S, which is 200, definitely not greater than 251. So we're going to use that equation for our subsequent calculation. So the answer is 269.64 as the minimum distance required. Okay? Right.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.